Hello and welcome back to the Cyber Education World. This is day second of our SOC Analyst training series. Okay, and in day first we explored how IT evolved. Okay, and today we are stepping into one of the most important topics, networking. Okay, the backbone of cybersecurity. As a SOC analyst, understand basic network components like IP addresses, DNS, DHCP, and subnetting. Okay, is not just helpful, but it is initial. Okay, and even if you are a complete beginners, don't worry, I will break everything down in a clear and simply way with example you can relate to. Okay, so today we are going to start with network security solution. But wait, why do we even need to learn or understand network security solution in the first place? And oh, there are many network devices, right? So why do we need security solution? To protect the network from bad actor. Okay, remember our IT evaluation video, we talked about different teams. Okay, one of their key responsibilities is to protect the network. Okay, and understanding network process is important to establish and secure connection at each level, like production server LAN or user LAN. Okay, and so on, and protecting the network, and that is where IDS come into play. Remember, the network is the backbone. We have to protect to prevent data loss. Okay, and protecting the network is crucial. For example, think about running a business. We discussed an Indian company earlier. Any business required support. Okay, that support often come from the networking team or a infrastructure team. Okay, who manage devices and services. But here is the issue, attackers are constantly scanning the network and looking for loophole to get inside. Okay, so why we need preventive solution? This solution can be grouped into two categories. Okay, first is a network security solution. Okay, and second is a endpoint security solution. Okay, for network security we mainly talk about firewalls, IDS and IPS, right? Firewall and intrusion detection system or intrusion prevention system or web proxy server. Okay, and email gateway. Okay, these are some of the most important network security solution. Understanding them give us to groundwork before we move on to the malware analyze, phishing analyze or SOC process. Okay, all right, let's start with the firewalls. Okay, what is a firewall? Have any of you heard of this term before? If you are already working in IT, or you probably have. Okay, so let's look at the basics network topology of an organization. Okay, in this topology we have a router, we have a switches. Okay, and a server LAN and a user LAN. Okay, and of course the internet. Okay, and the internet is the outside of the world. Okay, other companies, other clients, partners, and anyone who may be sending us emails, files, or other communications. Okay, but here the problems among these legitimate user, there are also bad actor. Okay, and you are already learned how switches and routers work. Okay, and how they route traffic using routing tables and IP addresses and so on. Okay, but remember, attacker can also do the same things. Okay, they can send request, fetch files, or try to communication with us. Okay, but we don't want their request reaching our organization. Okay, like a legitimate request should be allowed, but attacker request should be blocked. Okay, and to control this incoming and outgoing network traffic, we need the firewall. Okay, so what is a firewall? A firewall is a network security solution that monitor and control incoming and outgoing traffic based on predetermined security rules. Okay, when we say monitor, it means the firewall scan traffic, and when we say control, it means the firewall either allow or block the traffic based on those rules. Okay, and how does it scan? By using detail in IP packet header, like source IP, destination IP, source port, destination port. Okay, and based on the reputation of the IP addresses, and the firewall filters traffic, deciding what is the safe and what is not. Okay, and in other words, okay, it is a packet filtering device. Okay, okay, and if you are asked what is a firewall, you should explain it is a network security solution. Okay, and it's monitoring and controlling and incoming outgoing traffic. Okay, and it is a predetermined security rules, and it work at layer third and layer fourth of the OSI model. Okay, and apart from firewalls, or routers also work at a layer third, and switches at a layer second, and hubs at layer first. Okay, and modern next generation firewalls even work at a layer 7. Okay, and they also have a graphical interface and run on operating systems. Okay, for example, Palo Alto firewalls use Panorama OS. Okay, and the firewall can be a hardware devices, and rules are written into it. Okay, this process is called configuration. Okay, and the firewall, and then firewall those rule to allow and block traffic. Okay, so remember, firewalls can be a traditional or a next generation. Okay, now that we know what a firewall is, okay, next question is, where should it be placed? If we place it between the switches and server LAN, then yes, but the server LAN is protected. Okay, but what about the user LAN? Attacker could still attacker could still reach it. Okay, And if we put between the switches and user LAN, then the server LAN is left exposed. Okay, so where is the best place? The firewall should be placed between the router and internet. Okay, at the network perimeter. That's way it spread the organization internal network like a trusted zone. Okay, from the external world like a untrusted zone. Okay, think of it like inside the firewall is the trusted LAN and where employees and devices can safely work. Okay, and outside the firewall is the untrusted WAN. Okay, where unknown or unauthorized user exist. Okay, so simple example, when you log in into Microsoft Team as an authenticated user, you can use chat. Okay, because you are in the trusted zone. Okay, but if someone try to sneak into the session using just a public link, they will not have access to chat. Okay, because they are in the untrusted zone. And okay, and the firewall enforces this rule when a internal user makes a request to the internet. Okay, and the firewall checks its rule like is this request allow. Okay, if yes, it goes out, and if not, it is blocked. Okay, so if you are asked in the an interview, oh, like where is the firewall placed, the correct answer is at the first level and right after the internet, right after the internet. Okay, and between the router and the internet, and it spread the external zone from the internal zone. Okay, and always explain your answer as if the interviewer does not know anything. Okay, that is the best way to show clearly of thought. Okay, so far we have learned that there are two main zones. First is the internal zone and second is the external zone. Okay, internal zone is the trusted network, and external zone means the untrusted network. Okay, but there is also a third zone we need to discuss, the demilitarized zone. Okay, the DMZ is where public facing servers are placed, such as a web server, email server, and file transfer protocol server. Okay, so why are they placed here? Because both good and bad user will try to access them. Okay, for example, a customer may need to fetch your website or send email. Okay, those are a legitimate, but among them some attackers may also try to access the same servers to find vulnerabilities. Okay, and by isolating this server in a DMZ, we limit the damage. Even if a public server is compromised, the attacker does not directly gain access to the internal LAN network. Okay, let me give you a real world analog. Have you even seen an ATM machine inside a bank building? Usually, no. Okay, ATM are placed outside the bank in the separate zone. Okay, because the bank does not want everyone walking into the secure bank premise, okay, just to be use an ATM. Okay, and they isolate it. Okay, similarly, the DMZ is a buffer zone for a public facing system. Okay, and the bank keep it critical operation inside while giving a public access to ATMs and outside the in a controller zone. Okay, and the same concept apply to the IT network with a DMZ. Okay, but here is a question: what if a public facing server in the DMZ, say like web servers, email server, or file transfer protocol server, okay, gets compromised? In the case, attackers might try to use it as a foothold to move deeper. Okay, to reduce this risk, and organization often add multiple firewalls or additional security layers between the DMZ and the internet LAN. Okay, and they may also use endpoint security solutions, IPS, or proper configuration hardening to protect DMZ systems further. Okay, we will discuss this in detail later, but the key point is the DMZ isolates high risk, okay, and public facing system, so they don't endanger the trusted network directly. Okay, so now we know internal zone and external zone and DMZ. Okay, one thing remember, public facing services like a web server and file transfer protocol servers and email servers are always at a higher risk. Okay, because anyone from outside can try to connect to them. Okay, that's why we keep them in the DMZ. So even if they are compromised, the internal trusted network stays safe. Okay. And another point, companies often implemented different level of firewalls. Okay. For example, one firewall between the internal and DMZ, and another firewall between the DMZ and the internal LAN. Okay, so this way, even if attackers break into the DMZ, they face another layer of defenses before they can reach critical systems. Okay, so when it comes to cyber defense, and the firewalls is considered the first layer of protection. Okay, and it blocks unauthorized access and filter out malicious traffic right at the edge of the network. Okay, but keep in mind, firewalls alone are not enough. That's why we also have a IDS and IPS and proxy and other solution. Okay, because attackers are always involving, and firewalls are powerful, but they cannot detect everything. Okay, so especially advanced threats or zero-day attack. Okay, okay, now IDS and IPS. Okay, intrusion detection system and intrusion prevention systems. Okay, IPS and IDS are primary signature based, and behavioral detections lives more at the endpoints or and in modern analytics platform like and machine learning modern can flag suspicious activity, and if the confidence is high can block automatically. Okay, IPS and IDS are primarily signature based, and behavioral detection live more at the endpoint like a EDR layer and in a modern analytics platform. Okay, and machine learning models can flag suspicious activities, and if the confidence is high, and then it can block automatically. Okay, so, what if IPS signature are not up to date and new malicious traffic appears? And how will IPS cope? Okay, so remember we follow defense in depth, DID. Okay, we place many security solutions across the topology, so one missing signature does not mean total failure. Okay, if signature are not updated, and a 0 day can bypass signature based system. Okay, and a 0 day mean no one yet know the signature, so firewall IPS might not detect it. Okay, and the payload could be allowed. Okay, and an endpoint get infected. Okay, and the attacker may gain C2 and compromise systems. Okay, that's why behavioral detection and endpoint solution are very important. So signature based detection, IDS IPS, rely on unknown pattern. If there is a new malware with no signature, a 0 day signature system will not catch it. Okay, and endpoint security introduce behavioral detection. Okay, and it watches how a file or process behaves. Okay, and modern tool add like AM, artificial intelligence, and machine learning to detect anomalies and reduce attack advantage. Okay, so you will learn more about EDR and MDR in later session. Okay, and we will cover endpoint detection and response and automation orchestration. Okay, so when you know investigate, and you will rely on logs to know whether an event is from firewalls, IPS, IDS, or AD logs, or DNS, or DHCP. Okay, so different devices generate different log formats, like learning to read them is fundamental. Okay, after these basics, we will go to raw logs analyze in the next session. Okay, now the stateful inspections concept. Imagine you have a 100 MB file, okay, to send. The file get split into many packets, and you cannot write a firewall's rule for each packet individually. Okay, and it would be efficient and use. Instead, the firewall use the state table. Okay, and you write one rule on the firewall, something like allow traffic from a particular source IP to the destination IP, okay, and port, okay, and the firewall create a state entry for the connection and a store attribute for the session, okay, like a source IP, destination IP, and port and connection state, okay. Then the firewall inspect the first packet thoroughly. Once validated, the rest of the packet for the connection flow based on the state entry, not by reprocessing every ACL line. Okay, this is how a stateful inspection improve performance and scale. Okay, in other words, you don't write hundreds or thousands of rules. Um, you write one rule and the firewall track the session in the state table, okay, and the firewall stop processing ACL for that connection after the connection is validated, okay, until the connection in, okay, it keep processing efficient. Let's show a concrete ACL example to explain first match out. Okay, so if the firewall check top down a packet from like a 10.10.5.50, okay, to 30.40.50.60 will match rule A first, so it will be deny even through rule B would be allow it. That is why a specific allow rule must appear above board deny rule. Okay, order matter. So another practical ACL trick: use wildcard or prefixes to avoid writing and one entry per packet. For example, write 10 dot 10 dot and 5 dot and star, like anything, to 30 dot to 40 dot to 50 dot to 60 dot to cover the whole source subnet, and the ACL process each incoming connection against the rule top down, okay, and once a match it found, it applied that action and stop, okay, so put the exact match at the top, okay. When a ACL has a rule like any, it's include all specific IPs, so placing any above your specific allow will block the specific IP, okay, and this demonstrate first match out behavior clearly, and the firewall will not continue checking rule after a match, okay. The state table also record connection termination, okay, and when the connection end, it show like fin into connection, okay, like a finish, and or is reset, the then so is rest, okay, and the firewall remove the state entry, and you don't need to reprocess ACL for the same session while it is active, okay. That's why a stateful inspection boost performance, okay. And if you have not reviewed TCP flags like finish or reset from the basics networking, they matter for understanding connection lifecycle, okay. And important limitation: traditional firewall ACL and stateful inspection mostly inspect packet headers like source, destination IP, and ports. Okay, they don't inspect payload contents. Okay, so if a packet's payload contain a malicious content, but the header look legitimate, a header only firewall will not detect it. Okay, that's the major limitation. So that is where IDS and IPS and web and email gateway come in, and they can inspect and payload and application content. Okay, if payload content is malicious, IDS, IPS, or application gateways should detect it, like provided their signatures or detections rules to cover that pattern. Okay, thus firewall plus IDS, IPS plus proxies. Okay, together create better protection. If payload contains malicious content and it passes the firewall, because headers are allowed and IDS IPS must catch it. Okay, if signature are missing, then behavioral endpoint detection and defense in depth layer protect the environment. Okay, and remember, the network operation teams typically install and manage many of these systems, and SOC analysts focus on logs and detection and response. Okay, and every devices produce logs like firewalls, IDS, IPS, DNS, DHCP, AD logs, ADR logs. Okay, by analyzing the logs, you can determine where an event originated. Okay, that's why raw logs analyze is critical for SOC. So after we complete these fundamentals, you will start working with raw logs in detail. Okay, let's talk four machine like A, B, C, and D. Okay, and IP range like 10.10.1.1 to 10.10.1.4. Okay, and A is like facebook.com. Okay, and B is like amazon.com, and C is like some blog site. Okay, and D is magic.com. Okay, like a facebook.com, like a IP like X. Okay, the firewall checks top to bottom and find allow rule for A, I and IP like X. Okay, and permit it and stop further check for that for flow. Okay, and machine B amazon.com, like IP like Y. Okay, and then the firewall checks rules and find matching allow for uh, company like amazon.com, and machine like B for IP address like Y and permit it. Okay, and machine C some block site. Okay, the firewall checks and find deny or entry or blocked. Okay, and the machine like a D like a magic.com is handled similarly. Okay, and each connection is proceed independently and quickly. Firewall handles many such of flows per second using state table and ACL purity. Okay, it's like rail signals. Okay, like green for a current trend and red for others. Okay, rules are proceed per request. If you write a generic rule at the top, it will catch everything. So always design ACL top down, put a specific IP port allow first and deny later. Okay, that is what solves the reversed. Okay, and rules problem we demonstrated earlier. Okay, in practical, you will use a combination like ACL take care of quick header based filtering like ports or IPs. Okay, and stateful inspection tracks session efficiently, and deep content inspection like IDS, IPS, proxies look at payload and application behavior. Okay, and use them together for a strong defense. Okay, so signature detection look for unknown pattern like hashes, signatures. Okay, and behavioral detection watches for anomalies. Okay, and modern SOC use a AI and machine learning to spot deviation from normal baseline. Okay, if the modern confidence is high, the system rises alert or even blocks. Okay, and behavioral detection is crucial for botnets and unknown malware. Okay, and note IPS historically relied on a signature, and behavioral approaches are more common at EDR or MDR layer nowadays. Okay, and we will cover EDR and MDR in later session. Okay, so, as a SOC analyst, you will look at alerts and logs and correlate events across firewalls, IDS, endpoint telemetry, and DNS, DHCP, AD logs. Okay, so that is how you detect real incidents and investigate root cases. Okay, so now default gateway, the router that connect your internal subnet to the other network. The example like the internet, if your PC want to reach like 8.8.8.8.8 it send the packet to the default gateway which route it outward. Okay, now DNS, domain name system. Okay, DNS convert human reliable name like example like www.google.com, okay, to IP. Okay, think of DNS as the internet phone book like and humans remember the name and machine use IPs. Okay, and DS dynamic host configuration protocol. Okay, DHCP automatically assign IPs when device join the network, so you don't configure IPs manually. It ensure no two devices have to the same simultaneously. Okay, now a practical flow. A laptop connect to the Wi-Fi, DHCP assign an IP, okay, and laptop ping the default gateway to verify connectivity. Okay, like you type a www.google.com and your system ask the DNS server which resolve it to an IP, like example like 142.251.36.238. Okay, your request goes out via a gateway or a bypass the firewall if allowed, okay, and transfer the internet and reaches the Google and the page loads. Okay, this sequence so DHCP gateway and DNS and firewall decision working together. Okay, and it crucial to understand when you analyze log and incidents. Okay, now OSI model. Okay, the OSI model is a conceptual framework that standardizes the function of the telecommunication or computing system into the 7 layer. Okay, and each layer has a specific function and communication with the layers. Okay, so first layer is a physical layer. Okay, it's the lowest layer of the OSI model, and it's responsible for the actual physical connection between the devices. Devices like a hub, Bluetooth, Wi-Fi. Okay, and the physical layer contain information in the form of bits. Okay, and second is a data link layer. Okay, the data link layer is responsible for the node to node delivery of the message. Okay, and the main function of the layer is to make sure the data transfer is error free from one node to another node. Okay, and over the physical layer, and then network layer. Okay, and the network layer work for the transmission of the data from one host to the other located in the different network. Okay, and it's also take care of packet routing. Okay, and the fourth one is a transport layer. Okay, and the transport layer provides services to the application layer and takes service from the network layer. Okay, and it is responsible for the end-to-end delivery of the complete message. Okay, and fifth one is a session layer. And session layer is responsible for the establishment of connection and maintenance of session and authentication, and also ensures securities. Okay, and sixth one is a presentation layer. Okay, the presentation layer is also called translation layer. Okay, and the data from the data from the application layer is extracted here and manipulated as a per the required format to the transmit over the network. Okay, and last one is a application layer. Okay, we find the application layer which is implemented by the network application. Okay, and this application produce the data which has to be transferred over the network. Okay, and this application layer also called desktop layer. Okay, now web gateway. Okay, when I go with the web gateway, where should I place my web gateway, and why should I use one in the first place? Okay, a web gateway, also called a web proxy, is used to monitor users' web traffic, and it inspects HTTP and HTTPS traffic. Okay, and helps protect user from accidentally visiting malicious websites. Okay, and one powerful feature of the web gateway is website categorization and reputation. Instead of trying to block thousands of individual IP address or domain manually, which is impractical. Okay, and the proxy provides categories like gambling, sports, news, fashion, e-commerce, and social networking, and adults, and terrorism, and so on, and you can block or allow by category. That that save a lots of operational effects. Okay, so you can also use wildcards in proxy rules. For example, if facebook.com, for example, if Facebook will match many Facebook related domains, you can add entire to block list or an allow list. Okay, and this is how you create a general policies such as blocking or allowing groups of site without writing thousands of individual rule. Okay, and another key capability is malicious file or a download protection. Okay, the web gateway includes a built-in antivirus module. Okay, if a downloaded file matches a signature and the proxy will block it, that means web deliver malware can be stopped at the gateway before it reaches the user machine. Okay, and the proxy also help translate private IPs to public request and back user machine typically use private IP. Okay, and the proxy make the outbound request on their behalf and receive the response and forward it back to the correct internal host. Okay, and it is important because user devices in an enterprises don't have public IPs directly. Okay, so, in short, web gateway or proxy features you emphasized are like monitor HTTP, secure HTTP traffic and website categories and reputation lookups and wildcard and custom allow and block list and build in antivirus to block malicious download and protection against additional visits to malicious site and improve manageability. Okay, to like don't need to block every IP domain manually. Okay, so administrator and vendor claim proxies will block at least 99% of unknown categories based malicious site, not 100%, not 100%, but a high percentage. Okay, because of categorization and reputation services. That is why it is such a useful layer. Okay, let's cover the web gateway content, placement, and features. Now we'll move to the email gateway. Okay, the email gateway monitors incoming and outgoing email traffic, while the web gateway inspects HTTP and secure HTTP. Okay, and the email gateway focuses on mail protocols like primarily a SMTP, simple mail transfer protocols. Okay, for mail transfer and it sit in the flow to check policies on the mail in and out. Okay, in in your network topology you typically see two email server, one in the DMZ and one in the server LAN. Okay, why two? Because they serve different role. Okay, the email server in a DMZ is responsible for receiving and sending mail to from the internet and checking policies like spam, attachments, reputation, SPF, DKIM, DMARC, etc. Okay, the server in the internal and the server in the internal server LAN, like example like Microsoft Exchange. Okay, is responsible for storing users like mailboxes and serving mailbox access via IMAP or POP or exchange protocols. Okay, and internal mail between users typically does not hit the external gateway. Okay, it remains inside and is stored and served by the internal mail server. Okay, so the flow is incoming mail arrive at the email gateway DMZ. The gateway examine it against policies like SP, like spam, antivirus, anti-phish. or reputation check. Okay, and if allowed, it move to the internal exchange server where it is stored for the user. Okay, for outbound mail, exchange send mail to the email edge, and the edge check send policies. Then the edge forward mail outside if allowed. Okay, that is why the DMZ email gateway and the internal email server work together. Okay, the email gateway provides many features. First is anti spoofing, like SPF, D, DKIM, DMark check. Okay, and second is a anti phishing and social engineering to detect to detection using threat intelligence and machine learning. Okay, and third one is a antivirus scanning for attachments. If an attachment match a malware signature, the gateway can block the email. Okay, and fourth one is a spam scoring or a spam confidence and filtering. Okay, to block and quarantine spam. Okay, and six is a gray mail. Okay, to handling like mail that is neither clearly malicious or clearly benign. Okay, and seven is a file filtering. Okay, by name or by extension. Okay, example like executable documents or etc. by a file size. Okay, for anti-spoofing and header check, gateways show header info like DKIM and return path. Okay, you can view the header to see if an email is spoofed to like Cisco or Iron Pot flag is spoofed. Okay, email in headers. So analyst can quickly identify them. If a message is flagged, SOC can notify the user. Example like this is a spoofed email, please delete it and don't click link. Okay, and the gateway also give you SOC useful telemetry like spam score, subject line, attachments, who the message was sent to, and whether it was blocked, and whether it was marked as a spam, and file reputation. Okay, that's allow analysts to trigger did this email get blocked, and was it delivered, and was the attachment flagged. Okay, those detail come from the email gateway logs and UI user interface. Okay, and from web gateway, as a SOC analyst, you can track which website were visited and the username like mapped from IP. Okay, and how many times a site was visited, and bits sent received. Okay, and which browser was used, and any antivirus action taken on the machine. Okay, these are the field you will often query when investigating a suspicious web event. Okay, and from the email gateway you can analyze which email was received and attachments, and whether the email was blocked, and a spam score and subject line, and who the recipient was, and whether the sender was spoofed like a SPF, DKIM, DMARC, and okay, and the antiviruses and advanced malware verdict. Okay, and all of that is in the gateway's logs and UI user interface. That is what SOC analysts examine when triggering mail based incidents. Okay, that's wrap up day second of our SOC analyst training series here on Cyber Education World. We cover firewalls, IDS, IPS, web and email gateway, DMZ, ACL, stateful inspections, defense in depth, and key networking concept like DNS, DHCP, and subnetting. Okay, if you found this helpful, don't forget to like, share, and subscribe. Okay, so you will not miss day third, where we will move deeper into endpoint security solution. Okay, until then, keep learning and keep practicing, and see you in the next class.